Okay, welcome back. I hope you had a good weekend. This is Kevin Vandekar, starting back in with the 3ds Max SDK. We've got 5 more days this week, and this is Module 6, and we're going to be talking about geometry today. We're going to cover geometric objects and the different types of underlying geometry. So before we get started, I'd like to switch over and talk about the sample code. So we had Exercise 5, which was parameter blocks and function publishing. So let me switch over here to Visual Studio. So the first thing you're going to notice is, when you created the material object using the wizard, a lot of things were generated in this class. So material is one of the more complex things, so it's a bigger class, it has more functionality. That's part of it. But you'll see right at the top, there's the iParam block 2, and there's our pointer to it. Alright, so this is part of the reference system, and you can see even here there's a comment saying that it's ref 0. So if we scroll down towards the end, we can see here's the reference system implementation, and if we go to the set reference, you're going to see that the parameter block is in fact set up as a reference. Okay, and this is handled by the system. It's at index 0, so this is typically how it works. Now the other thing to notice, and we didn't really talk in detail about this, but there is a separate infrastructure for the parameter blocks itself and working with them. So there's also the number of parameter blocks, and it will, in this case, it returns 1 because we only have one parameter block. This you would have to bump up if you're having separate parameter blocks. And if you remember the geometry, the geosphere example, it had 3 different parameter blocks, one for the creation, one for the key in values, and one for the instance of the geosphere itself. So that was 3 separate parameter blocks, and that would, in that case, it would return 3. So in this case, we're just working with 1, and it's returning that parameter block. They don't even check the index. So this is default implementation. I'm not sure I perfectly agree with some of these things, so I would lean more towards being careful and not just rely on this this skeleton code. So you might want to check the index and make sure it's the right index and return the parameter block, and then that way if you add more, your code is already structured to handle that. Okay, so you were asked to add a parameter to the parameter block. So the first thing I did was I added this integer value to hold it. I also put the m_ on the 2 values that we're going to be kind of working with, just so I could see that they're the member variables and not confuse them with some of the other parameters that we're going to be working with. So I did that just for this sample. Personally, my coding style is to use the m_ for member variables, and I like the preface as well for the type. So you can see I did that on the new variable. So the new one is here. So then let's take a look at the parameter block itself. So first of all, here's the enumeration for the parameter block. So exercise 05 params, and this was generated for you. The enumeration here was also created for you. I added an enum for the new value 1. Okay, so this is the enumeration, basically the index for value 1. So the parameter block was also, the parameter block descriptor was also generated for you. So first of all, here is the parameter block descriptor start, and there's the name of it, and there's the class description. Okay, so all of this was generated. You can see it also auto-generated the auto construct and the auto UI, and as a result, the value for the float, which was called spin and identified as PB spin, was set up to have a spinner. Okay, so we wanted to add an integer that also had a spinner, so you could simply have copied this section here and pasted it at the end and give it the new values. So there's my enumeration for value 1, which comes from there. This is my new string for it. It's a type int, and it's going to be using the string from IDS val 1. Its default is 42, and 42 has some unique reference in some obscure science fiction, so points if you know where that comes from. The range, so I set up a range of 1 to 100 just to show that you can set a range, so that was up to you to decide. The user interface, so again it's a type spinner, this time it's an edit type int. We have an edit box that goes with it, and the spinner control, and the incrementer. And notice that this is still a float value, it's just the control incrementer, okay? And then the p-end for this block. Okay, so if we take a quick look at the RC file and the panel itself, you also had to add the controls for this. So I put mine up here, there's the static text, and here is the two controls, the spinner and the edit box. Okay, those are the things that are referred to here and here. Some of the other interesting things here to check and just look at while we're in this code is, we said p auto UI. There is some user interface things that need to be handled, so you can see that there's a create parameter dialog here, and we just simply use the skeleton code that was created by the wizard. So typically you don't have to really mess around with this, but in the case that you wanted to have a different type of dialogue, maybe you want to pop up a dialogue, or you want to have something else show, something custom, this is where you might where you would hook that up. There's also the set dialog thing, which gives you parameter dialog customization as well. So I'm not going to talk about the details of that, but you can see that there's some extra capability. And then also the auto construct, you'll see that right here is where we make the parameter block. And again, this is something that is typically done by the wizard code, and you don't necessarily need to worry about this default code, but it's good to know that it's there. So this is the call make auto param blocks. Alright, what that does is it basically goes through the param blocks and looks for the ones that are marked auto construct, and it will build them for you. Alright, if you didn't have this, the param blocks wouldn't get set up properly. And you could also create them manually at runtime in different places if you needed to. Okay, so let's just switch over to 3ds Max now, and let's take a look at how that material was set up. So I'm going to choose my material editor here, and I'm using the compact editor, but we could also use the slate editor. So I picked the material, and you can see there's my exercise 5, so I click that. I'm going to discard the old material, and here's the panel, the UI. Okay, so these are the default things that were set up by the skeleton, the wizard, and then this is the value that I added, and you can see that I can change it and do different things with it. Okay, so I'm going to move the material editor over here. I'm going to start the Max script window, and I just want to show a couple of things here. So you can see up here in the listener window that when I change something down here, the value changes up here. And this is part of the macro recorder, so it's enabled, but this is also part of the automatic parameter block exposure. So if I was to copy that down here and just simply assign it, let's say to point 2, you'll see that I can change the values directly, the parameter block values. So my new one was called material val 1, and when it was constructed it got the default value of 42, so I can set it to a new value, and you see it works here. It updated. So that's all part of the default parameter block behavior. So then the second part of the exercise was to do function publishing. So if I switch over here to the source code again, first thing you're going to see is that I did the public export. And we looked at this yesterday in the course material, so I'm not going to go through this in detail. This is the virtual interface function. And then the implementation, the function map description itself is here. So 3 arguments, the enum for the index of the function, the name of the function itself, and then the parameters. Okay. Now, to actually execute this, I do want to look at the implementation here just to show you how it works. In this case, this is called a core interface, so it's like a global function, and so it's not tied directly to our material. So there's ways of doing that, but that's a little bit more complex, and I just wanted to show a simple example. Wanted you guys to work through a simple example to get familiar with it. So the function itself takes a material as an argument, all right? And then the first thing we do is we take that material and we try to cast it to the material that we're able to work with, our material itself. Okay, and if that cast is successful, then the parameter is valid, and then we can go directly to the material and we can call its internal function called update main params base. All right, and that's a public function on the class right here. All right, so that makes it very convenient because all the implementation is here in the same file. So this public interface can only work with that material, of course, but it does give us a nice, easy, global way to get access to the material from something like MaxScript. Now, we also talked briefly about exception. There's an exception system for error handling. And so if the material is not of the type we want, then we just throw an exception. And this is a basic exception. It's not going to kill Max or anything like that. But what it will do is, in the case of MaxScript, for example, it will push this message to the MaxScript window, and you can also push an error code. Okay, and that's entirely up to you. And then the last part of this is the actual map, the description of the functions itself. All right, so this is what exposes it publicly. So our interface is going to be called update main params, and then these are the arguments that get exposed. So we switch back over to Max. Oh, and one other thing I wanted to mention before I run this. So the whole point of this was just to show a way of getting function publishing to work, so you could call into your class as you want. Now, remember, the parameter blocks themselves expose those 2 parameters. So we had our new parameter and we had the spin value. And what I wanted to show is just a way for you to call a function that will take the 2 parameters as in a single operation and update those 2 parameters at once. So we don't have to use, in the MaxScript, we don't have to use each property individual. So it's not a a very complex example, but the point here is that once you enter this function and you've gotten your type, you could pretty much do anything. So this could be an entry point for some algorithm, some logic that's within the material itself or within your plugin itself to do something. So it doesn't have to be just setting parameters. It can be any kind of logic that you want to call into from something like MaxScript. Right, so I'm going to go ahead and switch back over and just run this. I've got the syntax here in the paste and the copy buffer. So there's my interface entry point, the EX05. This is the function. Okay, so this is the interface name, and this corresponds to this. Okay, and this actually matches it. So if these were different, then it would default to it would default to this one. Okay, and then the function name, and then the input material, and in this case I'm just going to go off of the medit materials, so the material editor slot 1, which is what we worked on before as well. So I'm passing that material in as an argument this time. There's my floating point value and my integer value. Okay, so if we just go ahead and run that, you'll see should update. Okay, so 2 and 10. Now, just to show the error handling, if we were to pass in, let's say, slot 2, so let me build this up real quick, slot 2, and give it some values. And there you can see there's the exception that came back. Okay, so that matches the max exception. Error, not an exercise 05 material type, and my error code was -42. Alright, so pretty simple examples, but I think it goes a long way to showing you how the parameter block system works and how function publishing can be a huge benefit. Personally, I use function publishing a lot just to debug plugins. So I'm not an expert at MaxScript at all. I don't know it very well at all, so the built-in MaxScript stuff I'm not that familiar with. But it gives me a nice convenient context it's out of context with the plugin itself. It's a way to enter my plugin from another source. MaxScript is just so convenient for doing that. So I hope it was interesting, and again, if you had trouble or questions, go ahead and send me an email. Okay, so that brings us back to today's presentation. Today we're going to talk about geometry fundamentals, and the goal here is to talk about shapes and splines, then we'll move into patches, and then we'll talk about meshes. So first of all, a shape is an object made from one or more curved straight lines. A spline is a kind of shape based on the polynomial function. And a really good example to start with is to take a look at the Donut plugin. And this is in the samples within the objects subdirectory, and it's donut.cpp. It's basically made up of two circles which has an inner and an outer circle that make up the full shape. So shape and spline classes are listed here. The shape object is one of the fundamental base classes, and then you'll see that there's specifics that you'll use within the shape itself. Alright, so depending on what kinds of things you need to do, you might choose a spline 3D, or it might be a simple spline, it might be a linear shape. Okay, so this is where all of the base classes are located. So there's a copy base data member, and this is something that should be used by the derived classes to make sure that when you copy yourself, that you're also copying the data from the shape object. Okay, so this is like superclassing, but it's specialized functionality. And the reason we have specialized functionality is because it's used for shallow copy and also for undo and redo handling. Okay, so it's using the undo hold class. So let's take a look at building a shape. I'm going to switch over to Visual Studio. So I have the circle object sample code. This is from the SDK. And when you create an object of a specific type, the creation routines are called by 3ds Max, and the the plugin wizard will generate the basics for you. And so what you typically have to implement is the actual behavior itself. So in this case, we've got the circle object build shape, and this is what's going to be called when you start to construct one of these objects. So the first thing you can see we do is we actually get the values from the parameter block. Okay, so the parameter block is used to obtain and store values, but when we draw it, we have to actually pull those values out. So they're kind of like member variables, but it's also the storage place. So to be safe, you pull the values from the parameter block. And in this case, this build shape is calling another function called make circle. All right, so let's just take a look at make circle. So here you see make circle, and it's being passed in the Bezier shape, which was created up here. Okay, it's actually, I'm sorry, it's not even created, it's passed to you by the build shape routine. Okay, so you get a shape, and the first thing you should do is you should flush it. All right, so then we enter into our make circle, and we've got a clean shape. So we've also got the radius, so we can do some calculations. To define the circle, we're going to use a spline 3D. Okay, so from the shape, we can say new spline, and that's going to return us a pointer to the spline 3D that's part of this Bezier shape. So what we do now is we just basically iterate over the circumference of the circle, and we calculate the points to build that circular shape from a spline. So you can see spline specific logic here for adding the knots. So you'll see here, the loop is iterating over the knots that you're creating, and within the knot we construct a spline knot, and there's specific types. So in this case it's a Bezier, and it's going to be a curve, and these are the values that are being calculated. Okay, so I'm not going to go into the details of how to create a circle, but you can see how the SDK supports creating the circle through the spline. Okay, so once we have all the points, we close it so that we have a complete circle, and then we have to call compute Bezier points, and that just builds the spline so that when it draws, it's an efficient way of drawing it. Alright, so let's now talk about patches and how to build faces. So a patch is a 3 or 4-sided surface. Each edge of a patch is a Bezier curve, and each edge has a vertex at the end and a vector attached to each of those ends. So patches and faces have these principal classes. Okay, so we've got patch object, patch mesh, the patch itself, and then there's vectors, vertices, edges, and the TV patch. Alright, so let's talk about each one of these. First of all, the patch object is the base class for the creation of patch objects within 3ds Max. So it basically flows down the 3ds Max geometry pipeline, and it stores a patch mesh as well as a mesh cache. Okay, so it provides methods for working with the pipeline, while the mesh cache is used for displaying in the viewports. So then the patch mesh can be made up of any number of patches. So each of these patches can be 3 or 4-sided. So the topology of these patches are basically set up so that in order for the system to figure out how the topology is connected together, each edge can only be used by either one patch, which will make it an open edge, or 2 patches, which makes it a transitional edge between the two. So then that takes us to the patch object, which is like a fast face. Okay, so the patch mesh is like a 3D objects mesh. The patch is like a face within that mesh. Okay, so the patch contains the vertices, 3 or 4, and it also contains a set of vectors. It could be 6 or 8, depending on whether there's 3 or 4 faces. And those vectors go between the vertices, 2 per edge. There's also a set of vertices in the interior of the patch, and there's 3 or 4 of these as well. So then that takes us to the patch vector. Okay, so this represents the patch vector itself, and it can be either an interior vector or the edge vector. And then the patch vertice stores the information associated with a patch vertex and provides methods to access that data directly. And the information includes the vertex location, the table of the table of vectors attached to the patch, and a table of patches using that vertex. So it's kind of pointing back to the patches as well. And then there's the patch edge, and this describes the edge that are using the vertices at the edge ends, and the indices of the patches sharing the edge. And then finally we have the TV patch, and this is the texture vertex patch structure, and this is similar to a TV face, which is used within the mesh as well. So all of these classes sort of are unique to a patch, and they work similar to how the mesh works, but this is just a simple 3 or 4 vertice patch. So creating a patch. Well, first of all, the patch object itself is not really used as a class to derive from. So it's typically used in the context of other objects. So for example, I just did a search in all of the samples, and there is not a single case in the samples from the SDK that show patch object actually being derived from. So you can see in many of the cases they're using patch object as support. So for example here they're getting a patch object to set up capabilities within other objects. So then if we were to take a quick look at one of these use cases, you'll see here in this edit patch.cpp sample that they create a new patch and they're using it to build a patch from a shape. So let's just search for that. So here we go. This function is to create a quad patch layout. So it takes in a shape and it's basically building this patch mesh. Okay, so there's quite a bit of logic here to build it up, and I'm not going to go into the details, but you can see that there's quite a bit of functionality that's exposed through the SDK that will show you how to work with these patches when necessary. So the next section is about meshes, and meshes are really the root of all the geometry within 3ds Max. So most of the time you're going to be working with this object type. So we're going to spend a little bit of time talking about how to work with meshes. First of all, the definition is that it's basically a collection of primitive shapes. So basically edges and vertices. Those are the two fundamental data structures that make up a mesh. So there are 2 principal kinds of meshes within 3ds Max, and the most common is the triangular mesh or tri-object. Okay, so triangular mesh is represented in the pipeline by a tri-object, and you'll see this used in a lot of places. So make note of tri-object. And then there's another type of mesh called a polygon mesh, and this is made up of this is represented in the pipeline by the poly object. Okay, so triangular mesh is of type just mesh. Polygon meshes are made up of a type that's called MN mesh. Okay? So the mesh related classes are listed here: mesh, tri-object, face, TV face, adjacent edge list, adjacent face list, face element list, face cluster list. And then in addition to all of these things that make up tri-object style meshes, there's also the MN mesh, which has its own set of classes to support it as well. So again, mesh is the main class for working with objects that have meshes, that have 3D visualization capabilities. So it has data members that point to the vertices, faces, the texture vertices, and the texture faces. There are methods that are provided to access all properties of the mesh, and also to be able to render, to do things like snapping to the mesh. So individual vertices within the object itself, you can snap to vertices, and also the faces. So there are also methods that allow optimization, the ability to apply mapping coordinates, and to perform Boolean operations on the mesh. So you can take one mesh and Boolean it with another mesh. Okay, so mesh is really a fundamental class, provides a lot of capability. So then let's take a look at tri-objects. So this is basically all objects that should be able to convert themselves to a collection of tri-objects will work more fundamentally in the pipeline. Okay, this is one of the native classes that moves through the geometry pipeline, and it contains the instance of a mesh class. So then that takes us down into the face, which is a class used to hold a single triangular face of the mesh object. And this is important that it's part of tri-object and the tri-object's mesh, which means it is a triangular face. Okay? Maintains 3 indices into a vertex array of the mesh, and there are methods provided for setting materials, smoothing groups, and edge visibility statuses. And then there's the TV face, and this is the texture face, and it contains also an array of 3 indices, but it's specific to the texture vertex arrays of the mesh. And then we have the adjacent edge list, which is a supporting class for working with lists of edges. There's an adjacent face list, which is a support class for working with a list of faces. There's the face element list, again a utility support class to work with a list of face elements. And then finally the face cluster list, which is a supporting class for working with lists of face clusters. Alright, and then just to remind you again, the MN mesh is kind of a specialized class that allows capabilities to work with complex topology, such as the ability to recognize faces with more than 3 sides. Okay, so what I've seen is that MN mesh is used, when you are, importing or exporting things that need to have more complex mesh data. Okay, but within the context of 3ds Max, most of the time you're going to be working with tri-object and the standard mesh. So let's talk about how do you get the mesh. So first of all, you typically would go from a node and you would get the object's world state. So the inode eval world state method should be used to get the actual object state at a given time. So you can also use the original object state by getting the object ref from the node and then getting its state. Okay? So typically you would use eval world state to get it at its current time, or in a specific circumstance. Otherwise, you would go to the object reference that's stored in a node and just get the original object to use. So when we talk about edges, within a regular mesh, edge characteristics such as visibility and selection are referenced logically by face. So there is no real edge data structure. When we talk about MN mesh, edge selection and visibility data must be initially stored within the MN face members. So just know that things like edges specifically are stored differently depending on whether you're working with mesh or the more complex MN mesh. When we talk about face normals, so face normal is really the vector that defines which way the face is pointing. The direction represents the front or the outer surface of the face. So whichever direction that vector is pointing is considered the front. You can take the cross product of two edges of the face to find that face normal. And the length of a face normal vector is equal to twice the surface area of that face. Okay, so that's just a little bit of a tip to understand how the face area is also computed. Okay, it's just how the internal algorithm works. You can use the length of the face normal vector, which becomes equal to twice the surface area of that face. And then computing vertex normals. So you should, in this case, ignore smoothing groups. So then you take the single vertex normal for each vertex of the mesh. It's the average of the face normals of each of the faces that share that vertex. So first step is to allocate an array of normals, one for each vertex in the mesh, and then you initialize them to 0. Okay, so 0.3000. Then for each face, you compute its face normal, and then you add it into each of the 3 vertex normals that the face contributes to. And then at the end, you normalize all the normals in the array, and you'll have an array of vertex normals. So if you're going to consider smoothing groups, then you may also have to multiply normals for each vertex. So there may be as many normals as there are smoothing groups colliding at that vertex. So computing the vertex normals by weighting is one approach, and you would weight the normals by the vertex angle on each face, and then weight the normal using the area of each face. Okay, so this is kind of an advanced topic, and there's documentation that describes some of the details around this, but I just wanted to point out that computing vertex normals is totally possible, and that's how 3ds Max's pipeline works. So then to take a step back and start talking about how do you create good meshes, okay? And we call this pipeline-friendly meshes, so things that work efficiently in the pipeline. So first of all, referencing each edge at most once in each direction. Avoid self-intersection of faces. Avoid creating faces with vertices located at the same place. Okay, so don't duplicate. Don't bridge separate mesh components with a single vertice. Break the mesh into sensible elements, and then whenever possible, you should close the mesh. So don't leave holes in your mesh. There's different ways to do shells and thin-walled things. So most of the time now, in the current versions of 3ds Max, you should be able to create a closed mesh and represent your geometry that way. So that leads us to some sample code. So before we take a look at creating the mesh, I wanted to show, first of all, how you would get access to the mesh in an existing object and how you can work with the mesh. So the first technique you're going to use very often to find out what type of mesh is stored within the object is to look at its type. Okay, so here you can see it's getting the world state of the object at a specific time, and we have that now. And then they test on that object whether or not it can convert to the type that's called try-object. And if you remember, the try-object from the presentation is basically the fundamental geometry pipeline object that contains a triangulated mesh. Okay? If it can't convert to try-object, then it's probably the MN mesh. All right? So that's the first trick, is to check to see if it can even be converted to. And then oftentimes what you'll do is you'll actually convert it to the type, okay, and then receive back some sort of try-object that you can work with directly. So in this case, once they have it, this is a different part of the code, but they just go ahead and convert it to the type try-object, and then from a try-object you can get mesh, and it is of type mesh. Okay? And then to work with the mesh, so for example, once you have a mesh and you want to get, let's say, the texture vertices, for example, you just simply go to the mesh and you call its methods to get various aspects of it. So in this case, they're getting the T verts, and you can see they're just iterating over those for each one. They get the vertice, the T vert X, the T vert Y, for example. In this case, they're getting the actual vertices of the mesh. Okay, so calling get number of vertices, and then again they just iterate over in this block here, and they grab each vertice as a point, and then they do some work to convert it for the exporter. And then finally, you can even you should also work with the faces themselves. So here's the faces and the different aspects of this to iterate over the faces and check different parts of the face itself. Right. So for each face, there's going to be a vertice that make up the face, and these are the indices of the vertices to form the order in which the vertices are used to form the shape. Okay, so now we'll talk about creating the mesh, and while we're here, I'm going to also talk about how to create a plugin that will construct objects within the scene. So what I'm looking at right now is a sample that's in the how-to section of the SDK. So this is one of the tutorial style samples, and so it's documented pretty well. So you can see it's creating this widget, and it's derived from Simple Object 2. So Simple Object 2 is typically the starting point for an object. There's a couple of variations, but this is the newest one, and it provides the best fundamental support. So the first thing you're going to see here is that there's a mouse callback, okay, and this is for user interaction and constructing the object. There's some things that support the object, okay, so like the UVW, collapse types, intersection for the way things can be picked. Here's the begin edit params, end edit params, and then here you'll see there's build mesh, okay, and a couple of other things that have to do with displaying and updating the UI, but build mesh is where you would construct your geometry. Okay, you can see its superclass ID is a geom object, and this has the specialized class name widget. Okay, And then down here in this section, of course, you're going to see the parameter block support. So this has one parameter block to store the data for this object. Right? So if we take a quick look at the parameter block, its size, left and right, and you can see the parameter blocks here. So the begin and end edit params are what we talked about for the parameter block system. The different support that I showed in the class above. Here's the mouse callback stuff. So you'll probably want to review this to understand how the mouse can be used to construct things. Alright, so this is a really good example of how to use the mouse. And then here's your build mesh. Okay, and you can see that building a mesh is pretty primitive geometry construction. So for example, they know this widget is going to have 24 vertices, and that's going to construct 44 faces. Okay, so they build up their vertices first, and these are all vertices that are multiplied by its size. So that's what defines its point in space relative to some size value. Alright, and once the vertices are created, then they set up the faces. Okay, so you can see that this face at 0, the vertices to construct that is the 0 vertice, the second vertice, and the third vertice. So for face 1, it's this vertice, and this vertice, and that forms the triangle for that face. Alright, and then there's some edge visibility. So edge 1 is going to be visible, edge 2 is going to be visible, and edge 3 is hidden. And then the smoothing group. Okay, and that constructs the object. Now you can see that this is a pretty complex set of code, basically, to construct what is a widget. At the end, also I wanted to point out that once the mesh is completed, you have to invalidate its geometry cache, and that causes it to update for display. So something I want to point out that's in the documentation here is that there is a Max script that is called mesh to CPP, and it is located with the widget source code in the SDK. Alright, so I've got that script loaded here, a copy of it loaded here, and you can see that it's just a macro script, and what it does is it creates an action, and then you can add it to a UI element to run it. Okay, so that's what I did here, and I ran it on this pyramid. Okay, so you can see here this pyramid. I'm using my other little Max script to tell me how many faces and vertices. So it's got 8 faces and 6 vertices. And what this Max script will do is it will iterate the mesh within that pyramid and construct CPP source code like this with the exact sizes of that in space, so that you have a starting point to code your object from. Okay, so it's a very useful Max script. I would encourage you to take a look at it. So I ran it on this pyramid, and if we come over here, this is the header file it generated. You can copy and paste it wherever you want. It would typically go into your build mesh, and you can see that it's 6 vertices and 8 faces, just like here. And all of the vertices and faces are constructed according to how this mesh was built up. Alright, and this was just off of the standard pyramid geometry, and I converted it to an editable mesh so that the underlying mesh could be iterated. Okay, so very useful tool. Okay, I want to talk about a few other topics here while we're in the mesh subject. So first of all, vertex color information is stored with a mesh. It can be used in conjunction with the vertex color map or the color per vertex utility and modifier. So there's a utility and a modifier version of this. So you can see the sample code here for details. The materials vertex color is in this sample, and the utilities apply vertex color is in this sample. And then there's also the modifier. Okay, so all 3 of them are provided in the SDK. Texture vertices and texture faces. So the mesh class keeps a pointer to a list of texture vertices in addition to its regular vertices and are only allocated on a per need basis. So this is for performance and efficiency. So for example, if mapping coordinates are assigned to the mesh, then these extra vertices are allocated at that point in time. They don't exist until you explicitly perform the operation. And this is completely independent of the regular vertices and the faces in the mesh. So it's an extra set of data. So that's why it's important to only generate them when they're absolutely needed. There's a technique called mesh striping, which is the process of taking a mesh and turning it into a set of strips. And this is an optimization process. So without it, you always have 3 vertices plus 3 normals or colors that must be sent for each triangle. But with it, 1 triangle plus 1 vertex per additional triangle is sent, and this results in significant speed increase. So this technique is something that you would want to consider for very large meshes and very large geometric objects. So I would consider taking a look at this topic in the SDK if that's something you're going to be working with. And then finally, a topic in terms of building more complex geometry. So 3ds Max does have a NURBS system, which is the non-uniform rational B-spline mathematics. And there's a full section in the documentation about this. To use it, you would go into the surface_API.h, which includes all the major classes, and it is documented as well. And at runtime, you can also check to see if an object is a NURBS object by checking its class ID. So these are the high-level fundamental class IDs here. Editable surf class, fit point plane class, editable CV curve class, and editable FP curve class. So all of the NURBS math that is used in 3ds Max was pretty much taken from this NURBS book by Les Peigel and Wayne Tiller. So if you want the really nitty-gritty, deep details, that's a good book to take a look at. Okay, so let's talk about the exercise for tomorrow then. So it's a geometric object, and I'd like you to use the wizard to create a new plugin that is a procedural type. Okay, so that's the type on the first screen. And the object itself is going to look something like this. So it's going to have a mesh, and it's going to basically have 4 vertices, and you're going to create triangular faces to build this really fundamental closed mesh. So make sure that in the wizard that you choose the base class of simple object 2. So by default it sets itself to geom objects. So we want simple object 2, and this is going to gain us some default implementation and be the basis of this plugin. So in the new generated class, you're going to change the default spin parameter to represent a size value with a default size of 1.0 and a range of 1 to 100. Okay, so you know how to do the parameter block changes from the last exercise. I would encourage you to rename the default parameter from spin to something more meaningful. And then in the build mesh method, that's where you're going to implement this geometry. Okay, so first of all, note that the mesh is already a member of simple object 2. Okay, it's part of that implementation. And what you're going to need to do is set the number of vertices and faces. Okay, and it's a 4 vertice, 4 face object. All right. So you'll construct the vertices and faces based on the size. Okay, and the size you're going to need to pull from the parameter block. And then once you create the geometry, you'll have to invalidate it so you can see it. And then at this point, you should be able to create the object. It's going to be the size based on whatever the parameter block is showing via the dialog. And then optionally, I'd like you to think about adding the mouse procedure implementation to dynamically construct the size. Okay, so in the wizard generated code, there's a proc method in the create mouse callback. And you'll see that it's already got the first point case partially implemented. So here you're going to set the size to 0. Okay, and again use the parameter block. And then add a second case that's going to take the the second point mouse and build a size. Okay, so you might need to add something to the mouse class to track the previous point to calculate the size between the 2 points. So when it's fully working, it's going to look like this. And I've got it here spinning around, so you can see it's pretty basic geometry. I created this one right at the origin, so you can see that there's basically the 3 right angle sizes and then this other face which closes it up. All right, so if I was to create a new one of these, I'd just pick, and then you can see here that the mouse is being used to dynamically construct the size, and you can see the spinner is updating as well. Okay, and that should do it. So we'll talk again tomorrow, and I'll go through the exercise with you and just show you the implementation that I chose to make. Now we're getting into area where you can do things a little bit differently as you want, so I'd encourage you to explore things as you want. If you want to build a more sophisticated mesh, please go for it. And again, let me know if you have any problems getting started or getting through it. Thank you very much. See you tomorrow, same time.